Welcome to my kcse revision channel, Teacher Marita James, People's Business School. Kindly subscribe to my channel, click the notification bell, you get notified once I upload a new video. Today we are looking at chemistry, industrial chemistry, that is Form 3 work, sulfur and some of its compounds. So here I have done a summary of the whole topic where from the extraction of sulfur until where we have the uses of sulfuric acid. So as we know that sulfur is extracted by the Fransk process. In the Fransk process, we have three concentric pipes. We have the outermost pipe where we have a superheated water, and the purpose of the superheated water is to make the sulfur deposit underground. Then we have the innermost pipe where we have the hot compressed air. The purpose of the hot compressed air is to force the molten sulfur plus water out. And remember, this hot compressed air is compressed with a pressure of 15 atmosphere, and therefore it is forced through the innermost pipe, whereby now it can force the molten sulfur and water mixture out. Then we have the middle pipe. The middle pipe, we have the molten sulfur, so it conveys the mixture of molten sulfur and the water to the surface. Remember, the superheated water is heated at a temperature of 170 degrees to ensure that sulfur remains in a molten state. So having that one now, we have the Fransk process, which is the methods of extraction where it contains the three concentric pipes, the outermost pipe, innermost pipe, and then we have the middle pipe. Now, what property that makes that makes extraction possible? What property that makes this Fransk process? What property makes the sulfur to be extracted by this Fransk process? So we have properties that makes extraction possible. Sulfur has a low melting point. It is insoluble in water, or you can say it is immiscible with water. It has a low density than that of water. So these are the three properties which makes the extraction of this sulfur using the Fransk process very possible. Then this sulfur from underground, it contains some impurities. So what are the impurities of this sulfur? Impurities found in sulfur, we have sand, we have soil, we have silica, and then we have clay. So if you will be asked to name some impurities which are found in sulfur, you name sand, soil, silica, and then clay. Now from there, we have the allotropes of sulfur. Allotropy is the existence of an element in more than one form in the same physical state. Like in carbon, sulfur also exists in allotropes. So there are two allotropes of sulfur. We have rhombic sulfur and monoclinic sulfur. So we have these two, we have rhombic sulfur and then we have monoclinic sulfur. Rhombic sulfur can change to monoclinic sulfur, and monoclinic sulfur can also change to rhombic sulfur. When the temperature is above 96, the rhombic sulfur is unstable, so it gradually changes to monoclinic sulfur. When the temperature is below 96, monoclinic sulfur changes to rhombic sulfur. The temperature at which an allotrope changes from one form to another is called the transition temperature. So this 96 degrees is called transitional, the transitional temperature. So we have that one as a transitional temperature. So we have allotropes, rhombic and monoclinic. Rhombic will change to monoclinic when the temperature is above 96. Monoclinic will change to rhombic when the temperature is below 96. And that temperature where an allotrope changes from one form to another is called the transitional temperature. Then now we have chemical properties of sulfur. So chemical properties of sulfur, or you can also have the physical properties of sulfur, where we say it has a low melting point, insoluble in water, it has a low density than that of water. So we have the chemical properties of sulfur. Chemical properties of sulfur, it reacts with magnesium, with copper metal, or iron metal. With the magnesium, it forms magnesium sulfide. The observation you can see a white solid. With the copper, you can have copper 1 sulfide. The observation you can make is a black solid. With the iron, you will have an iron 2 sulfide. And the observation you can make there is a black solid. Then again, this chemical property can also react with concentrated acids where it can react with sulfuric acid. So if it reacts with sulfuric acid, you will have sulfur oxide plus water. What observation you can make here? So you will have a yellow solid dissolves. So you can have a yellow solid dissolves, and then you will have the purpose of the gas, and this purpose is of course sulfur oxide gas. So when it reacts with nitric acid with sulfur, so it can react, it can form sulfuric acid plus nitrogen oxide gas plus water. So the observation you can make here, a yellow solid dissolves, you can have purpose of a gas, and then you have a brown fumes. The brown fumes is a nitrogen oxide gas. Now we have from sulfur, we can now have sulfur oxide gas. In sulfur oxide gas, how is sulfur oxide gas being prepared? So we have the preparation. We have the preparation of sulfur oxide gas. So one we have, it can react, the reagents we have copper plus sulfuric acid. So you have copper plus sulfuric acid, and the condition you heat. So what you can see here is a brown solid dissolves, then you can have purples or a blue, purples, and then you will have a blue solution. You can also have this one here, you can react with, you can have another reagent for preparing this gas, whereby you can react sodium sulfide plus hydrochloric acid or sulfuric acid, and the condition is required here, it is heat. Now you will be correcting the gas. The gas collected, it must be dried, and the most suitable drying agent for this sulfur oxide gas is the sulfur oxide gas is collected, is dried using concentrated sulfuric acid, and therefore the gas is collected by the downward delivery, or what we call the upward displacement of air, because the gas is more denser than air. So it is collected by this method. Now, we have the chemical properties. In the chemical properties, it can react with water. When sulfur oxide reacts with water, it forms two types of the acid. We have sulfurous acid and sulfuric acid. So the sulfurous acid is an unstable compound. So you can have the sulfurous acid here, which can turn the blue litmus paper red because it is an acidic compound. This sulfurous acid now, it is the one which can be used in during the one which can be used in the bleaching action of sulfur, whereby when you take this sulfurous acid, when it reacts with oxygen, it combines with the dye. So it can combine with the dye. It forms a sulfuric 6 oxide, sulfuric 6 acid plus the dye. And this dye here now we have this one here. It forms a colorless matter. So this one here, we talk of the colorless. This is now it forms a colorless compound. The colorless compound, it is bleached. So this one here, you can explain the bleaching action of sulfur oxide. So the bleaching action of sulfur oxide, you start from having this sulfur, whereby they can react with water to form the two types of the acid, that is sulfuric 5 acid and sulfurous acid. The sulfurous acid is an unstable compound, whereby now it can combine with the dye to form a colorless matter, and this one here we call it it has been bleached. Now another chemical properties, we can have the acidified potassium permanganate. Acidified potassium permanganate, it is purple. So when it reacts with the sulfur oxide gas, it turns colorless. We can also have the acidified potassium dichromate, which is orange. So when it reacts with the sulfur oxide gas, it turns to green. We can also have the chlorine water. Chlorine water reacting with sulfur oxide gas, it can form a colorless hydrochromic acid. All of this one here, the acidified potassium permanganate, which is purple, turns to colorless. The acidified potassium dichromate, which is orange, turns to green. And the chlorine water yellow bromine water, it turns to colorless of hydrochloric acid, and that one gives us the chemical test for sulfur oxide gas. So the chemical test for sulfur oxide gas, the chemical test, we have acidified potassium permanganate, which is purple, acidified potassium nichromate, which is orange, and the bromine water, which is yellow. You can also have the iron 3 ions here, which is yellow. So when the iron 3 ions react with sulfur, it forms a green iron 2 ions. So another chemical properties, so you can have this sulfur, it can react with sodium hydroxide. Sodium hydroxide is an alkaline solution, so it is a base. When you react in a limited, you can have sodium sulfide plus water. When you have sodium hydroxide in excess, you will have sodium hydrogen sulfide. So these are the chemical properties. They can react with water, acidified potassium dichromate, acidified potassium permanganate, bromine water, iron 3 ions, and then you can have reacting with sodium hydroxide. So you can also talk of the oxidizing properties, whereby it can oxidize the magnesium metal to magnesium oxide and sulfur, and therefore you will be able to explain why sulfur continues to burn why sulfur oxide continue to burn, why magnesium continues to burn in a gas chamber full of sulfur oxide gas. So we can have this one as an oxidizing property. It oxidizes magnesium to magnesium oxide and sulfur. It is reduced to sulfur, and also you can also have hydrogen sulfide gas. So when sulfur reacting with hydrogen sulfide gas, it can be oxidized to hydrogen sulfide. This one can be oxidized to water, and then this one is reduced to sulfur. So those are the chemical properties of this sulfur. Now from there we proceed to have the hydrogen sulfide. In hydrogen sulfide, how is the hydrogen sulfide being prepared? So we have the preparation of hydrogen sulfide. You react the iron 2 sulfide with hydrochloric acid. You collect iron 2 chloride, which is green, plus hydrogen sulfide gas. So the observation you can make here, you have a black solid dissolves. You can have purples of the gas, and the methods of the gas collection, which is very, very important. The gas is collected over warm water. So during the preparation of hydrogen sulfide gas, you will see a black solid which dissolves, purples of a gas, of course, and then now the methods of collection is collected over water. Very, very important to note. Now, what are the chemical properties of this hydrogen sulfide gas? The hydrogen sulfide gas has a reducing property, so you can have reducing property is the same as that of sulfur oxide gas, but in this case now, where we have the hydrogen sulfide, you will have a yellow deposit of sulfur is seen. So you can have a yellow deposit of that sulfur is seen. So we can also have when the hydrogen sulfide is reacting with the water is reacting with sulfur oxide gas. So you can have, it can form a solution. So the solution we are using a solution, it is being dissolved. The gas is when dissolving in water, we are using a funnel. So a funnel is dissolved, it is used when the sulfur oxide is dissolved in water. And the purpose of this funnel it is to increase the surface area for this sulfur oxide to dissolve in water. Then from there, we can talk of now the contact process. In the contact process, what are you supposed to know? In the contact process, first you have to know the raw material which are used for the preparation of sulfuric acid. So we have the raw materials, we have sulfur, we can get sulfur either from the underground where we are using the transit process, or you can have this sulfur from the metal sulfide. For instance, you can have it from the zinc blende, a compounds of sulfur. You have it from iron 2 sulfide, compounds of sulfur. You can also have it from copper pyrites. Copper pyrites contain sulfur, or you can have it from a galena, a compound also contain sulfur. So we have sulfur, then we have air and water. Those are the three main raw materials required for the preparation of sulfuric acid. Now we talk of the main reaction. The main reaction takes place in the roaster, where we have now this sulfur reacting with oxygen to have sulfur 4 oxide gas. Then the gases must have to be purified. What is the purpose of the purification? The purpose of the purification is to remove the impurities. So we have the purification chamber. The purification chamber, it is done to remove the impurities. Then after the impurities, we can have now this gas. We take it to the drawing tower. And the drawing towers, we have the purpose of this one is to dry the gaseous mixture. Then from there, we have the compression, which is used now to compress the gaseous mixture, which has been from the drying tower. Then we have the heat exchanger. In this case, you need to know the purpose of the heat exchanger. Purpose of the heat exchanger is to preheat the gaseous mixture. Then we have another part, which is the catalytic chamber. In the catalytic chamber, there are the three conditions which are required there. One, you should have a temperature of 450 to 500. You should have a catalyst. We have two catalysts which are used. We have vanadium 5 oxide, and then we have platinum asbestos. But in this case, the vanadium 5 oxide is preferred instead of platinum asbestos because platinum asbestos is very expensive and it can poison. It's very poisonous. So vanadium 5 oxide is preferred because it is cheap and it is not poisonous. And now, when asked in an examination to give the conditions of temperature, a candidate or a student, you are not supposed to give the range. So you are not allowed to give the range as 450 to 500. Just say so this one is not required. You just write the specific temperature, the values which are between 450 to 500. So you can write 450, you write 470, 500, but it cannot go beyond 500, and it cannot go below 450. More of this one you will start in Form 4, the rate of reaction, factors affecting the rate of the reaction. So you will have a concentration, you will have temperature, you will have a catalyst, so you will get the temperature. There being explained the conditions required for that reaction to take place. So in the catalytic chamber now, we need to know the conditions. So we have a temperature of 450. We have a pressure of 2 to 3 atmosphere. So in an exam, you either write 2 or 3. Then we have the vanadium 5 oxide. And if you require, which is the preferred catalyst required, so you have the vanadium 5 oxide because of two reasons. It is cheap and it is not poisonous. Then now, the reaction now which can take place in the catalytic chamber, we have sulfur oxide gas combining with oxygen. Then you will have sulfur 6 oxide gas. So it is having the half arrows because it requires some condition to take place. A temperature is required, and then a catalyst is required. So in Form 4, you will start more of this one. What will happen if the temperature is increased? And remember, the type of this reaction is an exothermic reaction. So in Form 4, what will happen to the equilibrium when a temperature is increased? What will happen to the equilibrium when a pressure is reduced? So more of this one you will get in the topic of Form 4, the rate of reaction. Now we have the absorption chamber, where we have the sulfur 6 oxide gas reacting with sulfuric acid to have the helium. Now in this case, you might be required to explain how does this process takes place. Remember, the reagent, the raw materials we have is water. We are supposed to dissolve the sulfur oxide gas in water, but that is not the case. If we dissolve this one directly in water, it will form a mist, and therefore we are not going to collect the sulfuric acid. So sometimes we will be required to explain how does this process takes place. So this one takes place, you simply say, you take the sulfur 6 oxide gas, you dissolve in concentrated sulfuric acid, you form a substance called helium. Helium is this one here. Then you take this one in a dilution chamber, where now you can react it with water to get the sulfuric acid. Very, very important to note. So we have the dilution chamber, where now you will be having this helium reacting with water, so to form the sulfuric acid in liquid form. Then now you can have the uses of sulfur. Uses of sulfur, it is used for the manufacture of sulfuric acid. Then in the contact process, of course, you can also have it is used in the vulcanization of rubber. This one you will get it in Form 4, organic Chem 2. Then we have the uses of this hydrogen sulfide gas. The uses of this hydrogen sulfide gas, it is used in preparation of metallic sulfides. Metallic sulfides we have iron sulfides, we have copper sulfides, and so on. So we also have the uses of this sulfuric acid. In the uses of sulfuric acid, we have manufacture of solvent fertilizers. So some candidates write that it is used for the manufacture of fertilizers. That one is wrong because you can't score. You have to be very specific the type of the fertilizer. So in this case, you talk of the manufacture of the solvent fertilizers. That is a whole summary of the whole topic. And this one you can wake up one day very early in the morning, and then you revise very well. Then you will start having a summary of the whole exam. Kindly follow my channel, click the notification bell, you get notified once I upload a new video. Thank you.